Okay, and it is always about multiplication, otherwise division, because we know that division is the opposite of multiplication. They go hand in hand. Okay, it doesn't work with addition or subtraction. Okay, so we look at some examples today to look at how we can apply our law 4 and 5, which is what we have not yet covered. Okay, so looking at practice now. losing sight of what we are doing and end up everything is wrong. Okay, for part A, this will be how it looks like when we apply our law number 4. Okay? Okay, let's run through our answers. I think most of you are more or less done already. Okay, so I hope you are able to get part A. You understand what's going on. Let's look at part B. Okay. What I need you to check when you look through your own answers is to be careful about the presentation, whether you are using any important brackets or not. Okay, so negative 2c squared d to the power of 5 to the power of 5 again. Okay, actually refers to having our negative 2 to the power of 5, c squared to the power of 5, d to the power of 5 to the power of 5 again. Okay, you need not show me this step, okay, but this is for us to understand how the law number 4 is being applied. Okay, for law 4 being applied in these cases, I am actually not looking at this to this. I'm looking in reverse. That a times b to the power of n is equals to a to the power of n times b to the power of n. So I'm looking at the opposite direction. Okay, so now negative 2 to the power of 5, there's brackets around the negative 2. So you press that into your calculator, you will get negative 32. Okay, so this set of brackets is critical. Likewise for the rest, otherwise it doesn't make sense. Then after that, c to the power of 2 to the power of 5 again, we get c to the power of 10 because 2 times 5 is 10, followed by d to the power of 25 since 5 times 5. Okay, so that will be the answer for part B. Questions? Right? Next, we check part C. Okay, we have this for part C. Right? Very, very complicated, and this is actually a norm that you will see in your tests and exams. Okay, rather than the very simple ones like maybe 21 cube divided by 7 cube. Okay, so you can expect during any test and exam that you will look as complicated as this one. Okay, so we need to be patient and make sure that we do things one step at a time rather than to skip ahead. So the very first set of brackets over here, we bring the powers in. We can say h to the power of 8, k to the power of 4. So I'm now trying to skip a little bit of steps. I hope that you are able to understand how I get this. Okay, 4 times 2 is 8, 2 times 2 is 4. Followed by multiplying this other one, I have negative 5 to the power of 3, and that gives us negative 125. Okay, it is the entire negative 5 that undergoes power of 3. In case you're writing it separately, this is what we're saying. Okay, must have the brackets. Then after that, h cubed, k to the power of 15. Then in the denominator, we do the same. 5 undergoes the power of 3, we get 125. H to the power of 3 times 3, that's 9, followed by k. Okay. So now, I want to simplify things. Okay. Now that is actually everything is being multiplied to each other. There are hidden multiplication signs. Okay, like that inside. And I can shift things around very freely because we know 2 times 3 times 4 is the same as 3 times 2 times 4. Okay, so therefore I can write negative 125, which is a product of this, h to the power of 8 times h to the power of 3, that is my application of law number 1, for which I will get h to the power of 11 and then k to the power of 19 over 125 h to the power of 9 times k. Okay? Then now I need to further simplify because I cannot have h on both sides of the fraction and k on both sides of the fraction. Likewise, your 125 needs to simplify. So you can press your calculator, but negative 125 divided by 125, I hope we all know it's negative 1, for which we just write negative sign will be good enough. Followed by h to the power of 11 minus 9, that will give us 2. And then k to the power of 19 divided by k to the power of 1, that gives us k to the power of 18. Yes?
K is supposed to be k cube.
Oh, sorry, I forgot about that. Thank you. Okay, so one that is reached. Okay, 16 then. Right? Right, next we look at part D. In simplifying part D, 21 cube divided by 7 cube, we are looking at trying to apply our law number 5, okay, which is actually 21 divided by 7, then to the power of 3. For which I get 3 to the power of 3, and that is 27. Okay? Yes. Actually, first place exam 1 tested it. Okay? But we should write it as 27 rather than 3 cubes. So we should always compute it. Okay? Right? The exam won't ask you such question because what can we usually do? Just press calculator. Okay, don't really need to go and apply the laws. Right? This is just for us to understand how it works. Okay? Then part E. For part E, some of you were asking me earlier on, okay, isn't this already simplified? Alright, I do agree that this is actually somewhat simplified already since it is all put very neatly together, okay? But I think the question what it intended for is for you to understand how this is being applied. That was the intention behind the question, okay? For which I want us to be able to know that this is equivalent to a cubed over 64, right? Okay, 64. Next, we look at part F. Okay, for part F, we have this, for which, again, we do things one at a time. Tackling this first one, we know that it will become p to the power of 2 times 3 is 6 over q to the power of 3. Then we want to divide this fraction. Okay, so some of you forgot about your keep it change. Okay, but I saw that most of you remember that. So we just have to keep this, okay, and then flip this fraction and change this operation. Right? Then another problem that I noticed as I walked around, and some of you asked me, how do I multiply these two fractions together? Cannot cross, okay? Cross multiplying is only an equation when its fraction equals to a fraction. Now it's only within this space, okay? We can just cancel if you want to, but more importantly, in multiplying fractions, it is numerator times numerator, denominator times denominator. We don't need to change the denominator to be the same. Okay, it's not necessary at all, right? So you could actually write it in this manner first before thinking about cancellation. Okay, you may want to write it this way. Okay, then after you look at the p's, they will actually cancel out, or in fact we look at dividing, so we get p to the power 1. And then q to the power 7 divided by q to the power 3, we are looking at q to the power 7 minus 3, that's 4. Okay. Next we look at part G, the last one. Part G, we have 4x squared over x cubed to the power of 3, for which we will get 4 cubed x squared to the power of 3. Okay, I'm just trying to be intentional here. Okay, we're looking at it in this manner, right? for which you can, if you're fast enough, jump directly to this. Okay, looking at this left side first. Right? Then after that, on the right, we're dividing by a fraction. So we keep the change. And we have this. Okay, so again looking at fraction multiplied by a fraction. Right? Now, if you have the habit of doing cancellation, I just want us to be very careful in doing your cancellation. May I suggest that you use pencil in doing cancellation? Because sometimes your pen has a lot of ink, and then you cancel all over the place. I don't know whether what you're trying to write beneath it, okay? So it will be good to have pencil so that you can also erase and see very clearly. Right? So in this case, x's are all over the place. Right? It may not be that easy. Okay, because you cancel here, then after that, the other way, all over the place, it will get very messy. That's why I would recommend that you also merge everything together like what we did here. Okay, to get 64x to the power of 6 plus 21, that is 27, over 64 again. Then x to the power of 9 times x to the power of 7, that will give us 9 plus 7, 16. Having it written like that will be neater before you jump into cancelling. Because you don't want to cancel here, then after that cancel from here, and then I really don't know how you will go about cancelling. Okay, because there are x's everywhere. Alright? Keeping like that, we are very clear that we're only taking this and this. Okay? So 64 and 64 is 1. So then we're left with x power 27 minus 16, that will give us 11. Okay? Any questions? Right? We look at another one before we go into our zero and negative index. I think we start our lesson. 8 Oh no, do we have time for the break up so much. On Monday we come, so okay, we do this fast. Question 2. Given this, we want to find the value of n. Okay? So this is not your conventional question that we saw earlier on. Okay? So what we will do is that we want to find the value of n here. We can combine everything into 1 because they are all having the same base. So in other words, I can have x to the power 8 times x to the power 3n divided by x to the power 2n. I'll just write it like that first. To combine all this into 1, because it's multiplication, it means 8 plus 3n. Then because of division, we minus away 2n. So we can directly jump from here to here with the familiarity of the logs. Right? And that gives us 8 plus n. So because the base is the same, I can definitely say that the power must be equal. So I say that 8 plus n is equals to 10. And therefore, n will be equals to 2. Okay? Because there's no way, alright, for your 8 plus n to not be equals to 10 when the bases are the same. It must be that way. Okay? Right? Now we look at the very simple concept, okay, of zero and negative indices. We want to know what does 3 to the power 0 mean. I also want to know what does 3 to the power negative 1 mean. Okay? Actually, in our previous lesson, we already know that 3 to the power negative 1 is the same as 1 over 3. But I want to explain to us why. Okay? So, yes. Okay? So 3 to the power of 0 itself, okay, we think about this. Okay? My powers are in decreasing order. 3 cubed is actually 3 times 3 times 3, and that gives us 27. 3 squared gives us 9. 3 to the power 1 gives us 3. Okay? Moving down this order, what do we observe? 27 divided by 3 will then give us 9. 9 divided by 3 will give us 3. By this pattern that we observe, 3 divided by 3, it must give us 1. Okay? So therefore, 3 to the power 0 is equals to 1. Okay? So what I'm trying to conclude over here is that anything to the power of 0 will be equals to 1. Okay, so adding to this here, a to the power of 0 will be equals to 1. Okay? Now, then we continue from here. Okay, we know that 3 to the power of 0 is 1 already. And the pattern that we're observing is a division of 3. So the next integer of our power will be negative 1. Dividing by 3, that will give us 1/3. Okay? If I decrease another time, it will give us 1 over 9. And we know that 1 over 9 is the same as 1 over 3 squared. Okay? Then 3 to the power negative 3, by the same pattern, I also divide by 3, and that will give me 1 over 27, which is equals to 1 over 3 cubed. So what we see and understand over here is that the effect of the negative sign brings the base to the denominator. Okay? So it brings the base to the denominator, or in other words, we're looking at it as though it's shifting along the fraction, okay, from numerator to denominator, or denominator to numerator. Okay? So a to the power negative 1 will be 1 over a. A to the power negative n will be 1 over a to the power n. Okay? So that's our understanding of the laws of our indices and how it applies to 0 and negative numbers in ours. Okay? Now let's give this a try. If you're Kahoot, that's our 0 and negative indices. I thought y'all would lose the interest in powers already. Yes, if you don't have a Chromebook, please 36. Okay, so we write this fraction in this manner. Okay, so that's all I need. Okay, now this one, why in positive index form? Okay, so that means we from here negative index to positive index. Okay, what is the simplified answer? So denominator goes up, numerator comes down. Okay, and then we have 5 cubed over 4 cubed, which is 125 over 64. Okay, because right, based on this understanding, 4 over 5 to the power negative 3 is like 1 over 4 over 5, right? Which